Welcome to the video help for SBW Special Right Triangles 4.09. In this video, we will review 45, 45, 90-degree triangles, 30, 60, 90-degree triangles, trig ratio, SOHCAHTOA, and we will practice some SBW prep problems for your Geometry SBW 4.09. This type of triangle is a special right triangle called a 45, 45, 90-degree triangle. Notice it has a 90-degree angle here with two congruent angles. All three angles add up to 180 degrees. 100 minus 90 is 90. So 90 divided by 2 is 45. That's why we call this a special right triangle, 45, 45, 90. The reason that it's special is it has some characteristics about the legs that help us to solve for this right triangle. Notice that this right triangle was taken from a square, where all four sides of this square are equal to each other, and the angles are 90 degrees. When this square is sliced diagonally with a line called the hypotenuse, we now have a right triangle, and the side of the hypotenuse is the same as side times the square root of 2. So when we look at this triangle, we see that we have side, side, and then the hypotenuse, which is side times the square root of 2. Therefore, the value of C is equal to 6, and the value of D is equal to 6 times the square root of 2. We can quickly solve for special right triangles knowing these special features. This is another special right triangle called a 30, 60, 90 triangle. 30, 60, 90 triangles are taken from a triangle called an equilateral triangle where all of the sides are equal to each other. But in this case, we put a line down the middle called the altitude, and we've now created a 90-degree angle where we've cut this side in half, meaning that this side is equal to 2, which is the hypotenuse, and this longer leg, the altitude, is equal to side times the square root of 3. So for a special right triangle called a 30, 60, 90 triangle, we can easily solve for the lengths of the sides because the short side is, well, in this case, this short side is 8. The hypotenuse is always 2 times the short side. And the long side, or the long leg, is going to be side times the square root of 3. So what is the value of x? 2 times 8, which is 16. What is the value of y? 8 times the square root of 3, which is 13.8. 5, 6, 4, 0. Let's just go ahead and round this to the hundredths place. So we're going to use this 6 to give this 5 a shove. So we're going to say that this side is 13.86 for the value of y. Here we have another special right triangle. Notice that one of its angles is 60 degrees. 60 plus 90 is equal to 150. 180 minus 150 gives us that missing angle, which is going to be a 30, 60, 90 special right triangle. Remember that we've split this leg right here in half. So that means that the hypotenuse is 2 times that shorter leg. So if the hypotenuse is 2 times y, which equals 10, then that means we can divide 10 by 2 to see that y is equal to 5. And the longer leg is always equal to the shorter leg times the square root of 3. All right. Now, if they ask you what trigonomic function you're going to use to solve for a side, I want to review that really quick with you. So I'm going to erase this just for a minute. Let's just say that we forget all about our special right triangle magic and we kind of step back into our SOHCAHTOA. I'm going to circle my theta. Okay, my theta is 60 degrees. I'm going to draw an arrow to the opposite side. Notice that I'm looking for the value of y. So I don't need x and I don't have x. That means that I can't use my opposite side. So, or sine, is O over H, opposite over hypotenuse. I can't use that. SOHCAHTOA is cosine adjacent over hypotenuse. Notice I do have the adjacent side right here, and I also have the hypotenuse side right here. Now, tangent is opposite over adjacent, and I don't have either one of those. So in this case, if they ask me what trigonomic function I'm going to use, I'm going to use cosine. And that would give me cosine 60 y over 10. Okay, so we didn't need to use cosine 60 y over 10 because we used the values for the special right triangle of a 30, 60, 90 triangle. And we found that this side is equal to 5, and we found that the longer side is equal to 5 times the square root of 3. And then we found that the hypotenuse is equal to 10 because it's 2 times the shorter side. But now they're asking us, what is the length of this line right here called AB? Remember that this part of the line is equal to 5, and notice that this part of the line is equal to 26. We want the whole line, so all we're going to do is say 5 plus 26 is equal to AB. And then we're just going to add that together. So that means that AB is equal to 31. Now that kind of gives you an example of how you're going to use this information to solve this word problem right here. So we want to know what type of special right triangle this is. And you notice that because you've got one of your angles right here. And then we want to know what trig ratio we would use. So you've got your theta, you draw an arrow to the opposite side. Ooh, it looks like you need the opposite. And if you look over here, you've got the hypotenuse. So if you need the opposite, you've got the hypotenuse. Think about SOHCAHTOA. Which one are you going to use? And then the next question, what is the approximate measure of the height of the kite? So remember that you have a special right triangle here. I can't tell you which one it is, but then you've got this leg over here that's, shorter, and then you've got this longer leg here, and you've got the hypotenuse, which is 2 times the shorter leg. So you can probably figure this out pretty easy by multiplying side times, our special features here. But then they ask you an even crazier question. They say, what is the height of the kite from the ground? So what they want to know is you've already figured out this length right here, but now they want you to keep going and they want you to figure out this whole entire length, like the height of the kite to the ground. And they do tell you in the word problem that this short part is 76 centimeters. So that should help you because you're going to do h plus 76 centimeters to get the total height. All right, if you have any questions, holler at me and I'll be glad to help you out.